Today we are going to learn how to show the value of special angles of 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees by using a right angle triangles. We are going to start the lesson in evaluating trigonometric functions for 30 degrees and 60 degrees. Let's say we have a right triangle with an angle theta. Let's label the sides is opposite, adjacent and hypotenuse. We recall the definitions for sines, cosines and tangents. Sines is opposite over hypotenuse and cosines is adjacent over hypotenuse and tangent is opposite over adjacent. Now let's set the triangles theta here to 60 degrees. Recall that the sum angles in the triangle is 180, so if this angle is 60 degrees and the right angle is 90 degrees, and then the third angle here must be 30 degrees. Now let's flip these right angles over so that we have two identical triangles next to each other. We notice that the two 30 degrees angles in the top corners add up is 60 degrees. Now if we consider these new larger triangles, all of its angles are 60 degrees and it is an equilateral triangle and its sides have the equal length of hypotenuse. Let's indicate the length of the adjacent with this arrow, and we have another copy of adjacent side over here. Since the larger triangle is equilateral, so all sides of this side have the same length as the hypotenuse. So if it says that these adjacents have a length of x, then the adjacents have length x as well. Now the hypotenuse of the bottom is composed of two adjacents, each of length x. So it has the length of 2x. This means all the other sides of the equilateral triangles have the length of 2x. As well, now it's time to find the length of the opposite in the term of x. So we can use the Pythagorean theorem, which says that the 4x squared equal to the x squared plus opposite square. We solve for the opposite square, so we will have the 3x squared here, and we take the square both sides, so we have the opposite as the sub 3 multiplied by x. So now is the time for us to find the sines, cosines and tangents for 60 degrees. So since we know that the sine 60 degrees is opposite over hypotenuse, so we will have the opposite of sub 3x over 2x. We simplify it, so we will have the sub 3 over 2. And for cosine 60 degree is adjacent over hypotenuse, so we will have the x over 2x here, so we simplify it, so we will have 1 over 2. For the tangent 60 degrees, so we will have the opposite over adjacent, so we will have the sub 3x over x, so we simplify it. You will have the sub 3 over 1 or equivalent to sub 3. So now what about x 30 degrees? So we look at the 30 degrees over here. So for the sine 30 degrees, it will be its opposite over hypotenuse. So you will have the x over 2x. So we do the same for the simplifications. So finally we will have the 1 over 2. And for the cosine 30 degrees, is adjacent over hypotenuse. So we have the sub 3x over 2x. So we simplify it. We will have the sub 3 over 2. And finally is the tangent 30 degrees, so it's the opposite over adjacent, so we have the x over sub 3x, and we will have it equal to 1 over sub 3. Now we proceed to the trigonometric functions for 45 degrees. So we will have another right triangles here with the angles of 45 degrees here and 45 degrees here, and here will be the 90 degrees. So let's say one of the side is x and here should be equivalent to x2, and to find the length of the hypotenuse here, so you may use the Pythagorean theorem. So we have the hypotenuse square equal to x squared plus x squared, so we take square root both sides, so we have the length of hypotenuse as the square root of 2x squared, so we have the sec 2x. So to evaluate the sine 45 degree, cosine 45 degree and tangent 45 degrees, we use the definitions of sines, cosines and tangents. So for sine 45 degrees, we have the opposite over hypotenuse. So we take one of the 45 degree as the reference. So we have the opposite as x and the hypotenuse is set to x. So we just do the simplifications here. So we will have 1 over sec 2 or sec 2 over 2. And for cosine 45 degrees, so we have the adjacent over hypotenuse. So again, we have the adjacent x and the hypotenuse as sec 2x. So we simplify. We will have 1 over sec 2 or sec 2 over 2. And finally, for tangent 45 degrees, so we have the opposite over adjacent. So we have the x over x. So we simplify it and you will get 1. Okay, now we are going to evaluating the trigonometric functions for 0 degrees and 90 degrees. Let's say we have the right triangles with an angle theta. So theta is here. Let's label the side of opposite, adjacent and hypotenuse, and this is we use the same definition for sines, cosines and tangents. Let's see what is happening when the theta goes to zeros. So we notice that as the theta going to 0, okay, the value of opposite is approaching 0. So that means the opposite goes to zeros and the adjacent and the hypotenuse get very close in length. So therefore, for the definitions of sines of 0 degrees, so we have the opposite over hypotenuse, so we have the 0 over hypotenuse, that's why you will get zeros. For the cosine 0 degrees, so we have the adjacent over hypotenuse. So since the adjacent and hypotenuse get very close in the length, so we will have the hypotenuse over hypotenuse, that's why you will get equal to 1. For the tangents 0 degree, so we will have the opposite over adjacent, so we have the 0 for opposite, so we have the 0 over adjacent, so you will have the 0. For the case when theta goes to 90 degrees, let's see what is happening. So we notice that when theta goes to 90 degrees, the adjacent goes to zeros and the opposite and hypotenuse get very close in length. So therefore, to evaluate the sine 90 degrees, so we will use the opposite over hypotenuse. So opposite is the length of hypotenuse. So we simplify it. So you will get 1. So we have the sine 90 degree is equivalent to 1. And for cosine 90 degrees, so is adjacent over hypotenuse. So we have the adjacent of 0. So 0 over hypotenuse, so you will get the cosine of 90 degrees is equivalent to 0. And for the tangent 90 degrees, so is opposite over adjacent. So opposite is the hypotenuse and adjacent is 0. So you will get the value of undefined here. So tangent 90 degree is undefined. This table is the collections of the trigonometric ratios of special angles 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees for the functions, sines, cosines and tangents.